Imagine a future where we can travel to the nearest star system in just a few days. Picture exploring the vast stretches of the universe, seamlessly defying the conventional laws of physics. It sounds like something from a sci-fi movie, doesn't it? But what if I told you that we are inching closer to turning this dream into reality? In today's video, we'll explore the tantalizing possibility of warp drive technology, how it's becoming more feasible, and what it means for the future of space exploration. Strap in as we journey through the realms of theoretical physics, cutting-edge research, and the future of interstellar travel. The concept of warp drive. Warp drive has long been a staple of science fiction, immortalized in shows like Star Trek, where starships zip across galaxies at faster than light speeds. But beyond the fictional realm, the concept of warp drive is grounded in serious scientific inquiry. So, what exactly is a warp drive? The warp drive, as conceptualized by physicists, is a method of faster-than-light travel that doesn't violate the laws of relativity. Instead of moving a spacecraft through space, a warp drive manipulates space-time itself. This idea was famously proposed by physicist Miguel Alcubierre in 1994. Alcubierre's theory suggests that a spacecraft could achieve effective faster-than-light travel by creating a warp bubble around it. In this warp bubble, space-time is contracted in front of the spacecraft and expanded behind it. This manipulation means that the ship is effectively stationary within the bubble, while the bubble moves through space-time at speeds exceeding that of light. This method avoids the issues of relativity because it doesn't involve moving through space-time, but rather altering it. Theoretical underpinnings and challenges. Understanding warp drive requires delving into the complexities of Einstein's theory of relativity. According to this theory, nothing with mass can travel faster than the speed of light. This limit is due to the fact that as an object approaches the speed of light, its mass increases, requiring exponentially more energy to continue accelerating. To overcome this, Alcubierre proposed manipulating the fabric of space-time itself. By contracting space in front of the spacecraft and expanding it behind, the spacecraft could achieve effective faster-than-light travel without actually moving through space at superluminal speeds. This theoretical model allows us to bypass the constraints imposed by relativity, but it introduces new challenges, primarily related to energy requirements and exotic matter. The energy problem. One of the most daunting challenges in warp drive research is the energy required to create and maintain a warp bubble. The calculations suggest that it would require an energy equivalent to that of an entire star, or possibly even more, to achieve the necessary distortion of spacetime. This brings us to the concept of exotic matter, which is hypothesized to possess properties that could help solve the energy problem. Exotic matter would have negative energy density, a property needed to stabilize the warp bubble. Unfortunately, exotic matter remains a theoretical construct, and no experimental evidence or practical means of producing it currently exists. Enter solitons, a new hope. Recent research has introduced a fascinating concept that might address some of these challenges. Solitons. Solitons are stable, self-sustaining waves that maintain their shape and speed over long distances. They were first observed in the 19th century in fluid dynamics and have since been used in telecommunications to transmit signals over fiber optic cables with minimal loss. What makes solitons intriguing for warp drive technology is their stability and persistence. In telecommunications, solitons are used to transmit data over long distances without degradation. This characteristic is crucial for warp drive, where a stable and reliable energy source is essential. Dr. Eric Lent, a physicist from Germany, has proposed that solitons could provide a stable energy source for creating and maintaining a warp bubble. If solitons can be harnessed effectively, they might reduce the energy requirements for warp drive to more manageable levels, potentially making the dream of interstellar travel more achievable. Practical applications of solitons. Solitons are not a new phenomenon. They have been studied extensively in various fields. Dynamics. Solitons appear as stable wave formations that can travel long distances without dissipating. This property makes them an excellent candidate for energy transfer applications, including potential use in warp drive technology. In telecommunications, solitons are employed in fiber optic cables to maintain signal integrity over long distances. The stability of solitons ensures that data signals remain clear and strong, which is crucial for high-speed communication networks. Similarly, the stability of solitons could be leveraged to maintain the integrity of energy required for warp drive. Dr. Lent's research suggests that solitons could act as a medium for energy transfer, potentially solving some of the energy challenges associated with warp drive. By providing a stable and efficient means of energy transfer, solitons could make it possible to create and sustain the warp bubble required for faster-than-light travel. Exploring other propulsion technologies. In addition to solitons, several other advanced propulsion technologies are being explored that could complement or enhance warp drive research. Ion thrusters. These engines use electrical acceleration of ions to generate thrust. Ion thrusters are highly efficient and are ideal for long-duration space missions. They have been used in missions like the Voyager probes, which have been traveling through the solar system for over 45 years. However, ion thrusters produce low thrust, resulting in slow acceleration, which could limit their effectiveness for interstellar travel. Solar sails. Solar sails use the pressure of photons emitted by the sun or other light sources to propel spacecraft. This technology is highly efficient for long-distance travel and requires minimal fuel. By combining solar sails with soliton technology, spacecraft could potentially harness energy from stars and travel vast distances with minimal fuel consumption. Nuclear propulsion. Nuclear propulsion systems offer high thrust and are being reconsidered for future space missions to the Moon and Mars. Nuclear propulsion can provide significant power, but it also poses challenges related to safety and radiation. Spaceships equipped with nuclear reactors would need to address these concerns for long-duration missions. Real-world developments and research. Significant progress is being made in the field of warp drive research. Dr. Harold G. White, a former NASA scientist, has been leading efforts in this area through his Limitless Space Institute. Dr. White's team made a groundbreaking discovery involving a natural warp bubble created by the Casimir effect. The Casimir effect occurs when two metal plates are placed very close together in a vacuum. This phenomenon generates a small warp bubble, demonstrating that it's possible to create a warp-like effect using positive energy sources. Although the bubble discovered by Dr. White is less than 1 millimeter in size, it provides valuable insights into the feasibility of warp drive technology. Dr. White's work, combined with advancements in soliton research, represents a promising pathway toward practical warp drive technology. Researchers are optimistic that with continued advancements, we could see the development of functional warp drive prototypes within the next decade. The road ahead. Challenges and opportunities. The journey to achieving practical warp drive technology is filled with challenges. We need to address the technical and energy obstacles while exploring new theoretical concepts and experimental methods. The integration of solitons, advanced propulsion systems, and innovative research will be crucial in overcoming these hurdles. While we are still decades away from fully realizing warp drive, the progress made so far is encouraging. The potential for warp drive to revolutionize space travel and exploration is immense, and we are on the brink of a new era in space exploration. Conclusion. Warp drive represents one of the most exciting and ambitious goals in modern science and engineering. As researchers continue to explore and develop this technology, we move closer to a future where interstellar travel could become a reality. If you're fascinated by the future of space travel and want to stay updated on the latest advancements, be sure to subscribe to our channel. Thank you for joining us on this journey through the frontiers of space exploration. Don't forget to check out the video on your screen for more insights into the wonders of the universe. The quest for warp drive and the exploration of the cosmos are just beginning, and we're thrilled to have you along for the ride.